Okay, so in the previous video we focused on graphing our systems of inequalities and using the function that was going to be maximized or minimized to find the maximum value. Well, for this one we're going to focus on just reading a story problem and figuring out how we can set up our system of inequalities and how we can figure out what our function is going to be that's going to be maximized or minimized. Now, to help you out as you go through this worksheet, I start out with giving you a lot of hints, a lot of help. But as you go through, you're going to get to a point where there's less and less pieces that I include, where you have to start figuring them out for yourself, all the way to the end where there's going to be nothing there for you. Now, let's go to the first example here. The easiest way to go about doing, well, first let's read it and I'll tell you what the easiest part's going to be. It says, with the start of school approaching, a store is planning on having a sale on school materials. They have 600 notebooks, 500 folders, and 400 pens in stock. And they plan on packing it in two different forms. In package A, there will be 2 notebooks, 1 folder, and 2 pens. In package B, there will be 3 notebooks, 1 folder, and 1 pen. The price of each package will be $6.50 and $7 respectively. How many packages should they put together of each type to obtain the maximum benefit? Now, notice how I have this bolded. That's important here. This is going to be the key for getting these set up. This is our profit function right here, or a function that's going to be maximized or minimized. We know it's going to be maximized because they're asking for what's the maximum benefit going to be. The reason why that's so important is it tells you what your variables are going to be. Now notice it doesn't say too specifically, but it gives some hints. It says the price of each package. And there's 2 different packages. There's package A and package B. So for this, our variables are going to be package or A and B. Now we can see that from our table, but again, eventually as you're doing these on your own, you will not be given all these little hints. So you want to make sure that you know all the little tools you can use to be able to help figure out all these pieces. Okay, so now we know what our variables are going to be. They're going to be package A and package B. So now when I reread this, we're going to see what our individual inequalities are going to be working on. So it says they have 600 notebooks, 500 folders, and 400 pens in stock. Those are your totals. That means that's what they have available to us. They have 600 notebooks, 500 folders, and 400 pens that are available. They plan on packing them in 2 different forms. In package A, there'll be 2 notebooks, 1 folder, and 1 pen. So 2 notebooks, 1 folder, and 2 pens. In package B, there will be 3 notebooks, 1 folder, and 1 pen. So now all I have to do is fill this down with my variables, and I have my inequalities. I know these are going to be less than or equal to because that's all I have available. So I have to use either all of the 600 notebooks or less than that, or all of the 500 folders or less than that, or all of the 400 pounds or less than that. Remember, we have our 2 common sense inequalities that we're not going to have a negative amount of package A, we're not going to have a negative amount of package B. So now we have 2A plus 3B is less than or equal to 600. And then we have 1A, or just A, plus 1B, or just B, which is less than or equal to 500. And 2A plus 1B, or just B, which is less than or equal to 400. That's my system of inequalities. And now we're just going to convert that sentence that I highlighted there to be the fact that that function, to be maximized, is going to be 6 times, or 6.5A, or 650A, however you want to write it, plus $7 times B. Or I could have just said 7B. And that's all we're doing. Now, this was easy because it was given to us as far as the table is concerned. Now, some of them are not going to be that simple. Now, let's look at number 6. Now, number 6 on your worksheet, I didn't give you these variables, so let's pretend you can't see those right now. It says, on a chicken farm, the poultry is given a healthy diet to gain weight. The chickens have to consume a minimum of 15 units of vitamin A and another 15 units of vitamin B. In the market, there are only 2 brands of chicken feed. Chex Mix has a composition of 1 unit of vitamin A to 5 units of vitamin B. Plump 'em Up has a composition of 5 units of vitamin A to 1 unit of vitamin B. The price of Chex Mix is $10 a bag and Plump 'em Up is $30 a bag. What are the quantities of each type of feed that has to be purchased to cover the needs of the diet with the minimal cost? So we're trying to figure out how we can, again, the last question tells you what we're trying to look for. We're looking for how much we need of each type of feed to figure out what the minimal cost is going to be. So this is going to be one where we're going to have a function that we're going to be minimizing. And this is our key here. This is telling us how much we have to pay for each of these, and we're trying to minimize that function because we're trying to minimize our cost. So this gives me the hint, the fact that Chex Mix is going to be one of your variables and Plump 'em Up is going to be your other variable. So that's why we can set this up with our column headings being Chex Mix and Plump 'em Up. Now if we go back to the beginning, it says chickens have to consume a minimum of 15 units of vitamin A and another 15 units of vitamin B. So that tells me that my inequalities are going to be dealing with vitamin A and vitamin B. And we have to have a minimum, a minimum of 15 units for each of these. So that means it's got to be at least 15 or more units of vitamin A, and the same with vitamin B. So now to fill in the rest of it, it says Chex Mix has a composition of 1 unit of vitamin A to 5 units of vitamin B, and Plump 'em Up has a composition of 5 units of vitamin A to 1 unit of vitamin B. So our inequalities would be C, if I fill this down, fill the P down, so it would be C plus 5P is greater than or equal to 15, or 5C plus P is greater than or equal to 15, and my C has to be greater than or equal to 0, and the P has to be greater than or equal to 0. And my function that's going to be, in this case, it's going to be minimized. It's going to be 10C. It costs $10 for each bag of Chex Mix, and it costs $30 for each bag of Plump 'em Up. Let's look at one more example. I know on your worksheet it says to do one of these, so we're going to do this. We're going to do this first one together, so that way you can do the other one on your own. So this one I have everything stripped completely away. So you're required to solve this whole thing on your own without having a table, so we don't even know how to set it up. So that's why it's so important to learn these tools as we go through them. It says SA Electronics manufactures CD and DVD players. The manufacturing plant has a capacity to manufacture at most 750 CD players and 500 DVD players in 1 month. It takes 2 hours to make a CD player and 5 hours to make a DVD player. The company could spend no more than 3,000 hours manufacturing these products. SA Electronics makes $4 profit on CD players and $7 profit on DVD players. To maximize profits, how many CD players and how many DVD players should they make? And what is the maximum profit? Now, even though it says in part B to figure out a function be maximized or minimized, it's best to always find that one first. So now I know that I'm going to maximize this function, because again, the key there is we're trying to figure out how to maximize profit. So I'm going to do that over here. This will be part B. So it's going to be $4 for each CD player and $7 on each DVD player. So we're going to write this as a function. So we'll say f of, we'll use C for CD player and D for DVD player. And we make $4 on each CD player and $7 on each DVD player. So that's our function that's going to be maximized. And again, the reason why that's important is that tells me what my variables are. Now this one's a little different from the previous ones we've looked at. Now usually a table is there to help us if we have a lot of information that we're trying to organize. In this one, there's really not that much information we're organizing. Let me explain. It says a manufacturing plant has a capacity to manufacture at most 650 CD players. And that's really all it's referring to as far as manufacturing. The most they can do is 750 CD players. So I'm going to say that C has to be greater than or equal to 750. And D has to be greater than or equal to 500. Now it says it takes 2 hours to make a CD player and 5 hours to make a DVD player, and they can spend no more than 3,000 hours manufacturing these products. So that means that's our only other inequality, is the fact that it takes 2 hours to make a CD player, and it takes 5 hours to make a DVD player. And they can spend no more than 3,000 hours, so it's got to be less than or equal to 3,000. And again, don't forget our common sense inequalities, that C has to be greater than or equal to 0, and D has to be greater than or equal to 0. Did I forget that in the last one? Nope. Okay. And that's your answer. That's it. So hopefully this helps, just to give you a hint as far as the way number 7 worked. Number 3 and 4 on this page are going to be the same way. Notice how there is columns. You don't have to use these columns. I'm sorry, these 2 rows. You don't have to use those 2 rows because those are setting it up for the part that we just did, like these 2. So when you're looking at 3 and 4, you may not want to use the whole table or the table at all. But the table is just there to help us in some situations to be able to organize our information. So hopefully this helps with how to set up these inequalities. And in the next video, you're going to see how this all comes together.